Hello everyone again, welcome back. Today we are going to do example 2 in terms of solving rational equations. Okay, we talked about the need to first find the domain of the variable, then multiply each side by the least common multiple, and then we solve. The domain is important to find because we're going to see if the answer that we find should be excluded. Okay, if we find that our answer, our solution for the variable makes the equation go undefined, then we can't accept that answer. Okay. Now, let's look at this equation. First off, you should recognize that in order to find the domain, we need to factor this, okay? We don't like it when it's not factored completely. It makes it a lot easier for us to factor. So the first step we should do is we should factor everything. So I'm going to go ahead and rewrite this equation, okay? And now I'm going to factor it. I should recognize that this is difference of squares. So I'm just going to put it into my pattern here, x plus 3, x minus 3, because x is the square root of x squared, and 3 is the square root of 9. One needs to be plus, one needs to be minus, okay? Now this should make it a lot easier for us to determine our domain, okay? So look here, we're going to look to the denominators, and we're going to see what values of x make the denominators go to 0, okay? So what value makes x minus 3 go to 0? Remember, it can't equal 0, so that's going to be an exclusion. So our domain is all real numbers except for which values? Well, I'm just going to add 3 to both sides, add 3, and I know that x cannot equal 3. So that's one of our exclusions. So if I put 3 into this equation, I'd get 2 over 3 minus 3, or 2 over 0, and that would be undefined, which is no good. It can't accept that, okay? Pause it if you want. I'm going to erase this shortly. 3, 2, 1, erase. Okay, now let's go to the next fraction. We have 3 over x plus 3. Again, let's take a look. What will make this denominator equal 0? And that's going to be an exclusion from our domain. Well, we need to subtract 3 from both sides. We get x is not equal to negative 3. Okay, so that's another one of our, this one has 2 restrictions. Okay, it cannot equal 3 and it cannot equal negative 3. If we go over to the third denominator, we see we get the same thing. Okay, negative 3 will make this one go to 0. And, whoops, not a comma there. And then positive 3 will make that parenthesis go to 0. So our domain exclusions stay the same. It's still 3 and negative 3. Okay. Now I'm going to erase all this just to make it a little bit more neat. Okay, so pause it if you want to rearrange it or copy paste it or whatever, but I am going to free up some space. Okay. And let me get rid of these two. Okay. Now, this is kind of the tricky part that most people struggle with. I need to determine what I need to multiply both sides by in order to get rid of the denominator. Remember, it's the least common multiple. What does x minus 3 go into? What does x plus 3 go into? And what does x plus 3 times x minus 3 go into? Usually, you should check the biggest one. And sometimes, a lot of times, these other two are going to be factors of the bigger one. And that's the case here. X minus 3 times x plus 3 is a factor of x plus 3 times x minus 3. And then x plus 3 is a factor of x plus 3 times x minus 3 because you multiply x plus 3 times x minus 3. Okay? It's a long way of saying that you multiply these two together to get this one. So this one is your least common multiple because the other two fit, aka are factors of the other one. So this looks long, but it's not too bad. We're going to do x plus 3 times x minus 3. Okay? Now I'm going to write this out. This is going to be kind of painstaking, and you don't have to do this. Once you get a little bit more comfortable, you can just do this on the fly and cancel as you go. But I'm going to just show you the long way to do it, just so you don't get confused. Okay? And more practice makes perfect, obviously. Okay? I'm going to put this in parentheses too, because we're about to do some multiplication. Then we have 12 over x plus 3 times x minus 3. Okay. Now I've already decided that I'm going to multiply both sides by x plus 3 times x minus 3. And I could put this over 1. I'm just going to put it in the numerator because it's the same thing. If you multiply a fraction by a whole number, then it just essentially gets multiplied to the top. Okay, I multiply that one, done. I'm going to multiply this one now. So I need to multiply this by x plus 3 times x minus 3. Okay, and then lastly, I need to multiply it by the third fraction, x plus 3 times x minus 3. A little bit painstaking process if you write it all out, but again, you can do it in your head as you get better. This is the cool part. The whole reason why I decided to do this is to get rid of the fractions. And we'll see that this x minus 3 cancels with the term in the top, x minus 3, so that cancels out. What are we left with? We're left with 2 times x plus 3. I'm going to move it up, actually, just a little bit. There. Keep the minus the same. Okay, the x plus 3 cancels with that x plus 3. What are we left with? 3 times x minus 3. Equals, look what happens here with our big denominator. The x plus 3 cancels, x minus 3 cancels. We're left with just 12. That looks a lot better than it did before, and we're ready to proceed. First thing I would do is I would distribute. So I have 2x plus 6 minus, now I like to think of this as a negative 3 times x and a negative 3 times negative 3. So I get negative 3x, and then I get plus 9. Okay, a lot of people make that mistake. Don't be that person. Now I'm just going to combine like terms. I have a negative 3x and a positive 2x. And then I have a 6 and a 9. So let's go ahead and do that. I'm going to continue to use green. So let's do that here. I get negative x plus 15 equals 12. I subtract 15 from both sides. What do I get? I get negative x equals negative 3 divided by negative 1 or multiplied by negative 1, either or. And I get x equals positive 3. Now, before I say this is my solution, what do I have to do? I have to check it with our domain. Are there any restrictions that my solution violated? And the answer is yes. Look here. X cannot equal 3. We already said that. If we put in 3 here, it would make the equation go undefined. So our only solution that we found is bad. This cannot work because it's exclusion from the domain. So it is a no solution. Or no solutions, I should write. Okay, no solutions is our answer because our solution violated the domain. Hope this was helpful. See you next time.